This project name is Model-Free Neural Painter. The objective of the project is to train an agent that is able to reproduce images as real paintings are generated, through a series of brushstrokes instead of generating the pixels all at once. In the traditional reinforcement learning setting, our agent will be the painter, and its actions will be brushstrokes onto the environment. The environment will be a canvas, and its state will be the observations given to the agent. The agent will receive a reward based on the similarity between the target image and the image it produced. If we look at similar projects, we find Neural Painter, which train a generative model, which can be a variational autoencoder or the generator part of a generative adversarial network, to map different stroke parameters to a pixel grid with a brushstroke in it, thanks to a synthetically generated dataset. Then this action is repeated a number of times, obtaining a network which has a tensor of action space by number of strokes by batch size as input and outputs a number of paintings equal to the batch size. This network is fully differentiable, and we can train it end-to-end, considering this input tensor as weights. A second approach uses a more complex architecture with a model-based approach and a discriminator in order to model the reward. We will go for an intermediate approach between these two. We fine-tune again Neural Painter with a custom brushstroke and a synthetically generated dataset, and use it to generate this brushstroke into the canvas. In the left we have the actions, and in the right we have the brushstroke it can produce. For getting the representation of the state, a training inception network is used. It takes the pixel grid as input and outputs a vector that will be used by the agent as the environment observation. For each episode, the agent is allowed to make 30 brushstrokes. This is the final training architecture. Two different algorithms were tried, DDPG and PPO. We can see here that we modeled the reward calculating the L2 distance from the resulting image to the target image, in this case, La Gioconda. Here we can see the training curves for both of the algorithms. We can see that DDPG outperforms PPO. But if we take a look at the curves, we can see it learns something in the first episode, but then it plateaus, generating dark images that resemble more the target than bright images, but still staying in a local minima. Unfortunately, and after many attempts, the algorithm did not converge and it didn't produce any image that qualitatively resembled the target image. Anyway, here I show some results from the latest episodes. Some improvements can be made to the project. For example, we can leverage the potential of the fully differentiability of all the agent modules, since currently they not conform one single computational graph. Also, we can explore on how some change on the reward can affect learning. And in the end, we can make some hyperparameter tuning that can, for example, foster exploration more. Anyway, we got some interesting results and space for improving this project. Hope you like it, and thank you for your attention.